Hello friends and students, welcome you all to the first session of class 9th, and we are going to start with science and precisely with physics, the first chapter motion, and in the lectures which follow we'll be covering force, then gravitation and sound also, but today we are going to start with the very first chapter of physics, that is motion. Students, in this time of lockdown, would you say everything seems to be at rest? Now look at this diagram. This is A and this is B. And in the background, you can see these trees, this rabbit. Now, what can you say about the state of A or state of B or the state of this car or the trees or the rabbit? Yes, please answer. Are they in rest or are they in motion? I can see most of you are answering in yes, that they are in rest. But please look at this case. What if this car starts moving in this direction? Say this is east and this car starts moving in this direction. To an observer sitting in this car, the trees would seem to be rushing back. A would seem to be moving in the opposite direction. Even this rabbit will seem to be moving in the opposite direction. And of course, A will see the car as moving, B will see the car as moving, everyone will see that the car is moving. But to the observer in the car, everything seems to be moving in the opposite direction. Now, what is motion? We can take another case. Here, you see a bus standing on a road, and B and C are sitting in this bus. Now, suppose this bus starts moving in this direction. Now A would see B as moving towards this direction. A would see C moving in this direction. But what about B and C, irrelative of the surroundings? B will say that C is at rest. C will say that B is at rest because when they are sitting in the bus, they the distance between them doesn't seem to be changing. So it is not very easy to define motion in an absolute way. It is a relative term. So, what is the definition of motion? तो बच्चों आप डिफाइन कर लेते हैं कि मोशन क्या है. Motion is defined as the change in position of an object with time, of course with respect to an observer. So here again an example is there. On earth there are two people, A and B, and A is saying that B is at rest, B is saying that A is rest, nobody is in motion. But this observer, C, who is on moon, is saying that A and B both are in motion. So आप भी रोज देखते हो, हम लोग एक दूसरे को रेस्ट पे बोल सकते हैं कि हाँ मेरे पड़ोस में जो चेयर पे बैठा है वो रेस्ट पे है. लेकिन इमेजिन कीजिए अगर कोई मून पर बैठा है तो उसे क्या लगेगा कि हम लोग घूम रहे हैं. तो यही मैं समझाना चाहती हूँ कि मोशन इज with respect to an observer. It is a relative term, it's not an absolute term. अब ये जो मोशन है ये कई टाइप्स की हो सकती है. मोशन कैन बी one dimensional, it can be two dimensional, and it can be three dimensional. One dimensional motion means only one coordinate changes with time, like my pen is moving almost in one dimension. A train moving between two stations on a big distance, or the stations which are very far apart, will also be said to be moving in one dimension, right? But motion in two dimension means, look at my pen, it is moving in two dimension, right? It can move left, right, and you are familiar with math, so it is changing its x coordinates and y coordinates, but it is not leaving this plane. So this is in two dimension. Now what about a three dimensional motion? थ्री डायमेंशनल का मोशन का एग्जाम्पल आप ले सकते हैं कि जैसे एक मॉस्किटो रूम में फ्लाई कर रहा है, या फिर बच्चे फुटबॉल खेल रहे हैं और फुटबॉल की जो मोशन होगी इट विल बी मूविंग ऑन द फील्ड एज वेल एज मूविंग इन स्पेस. सो व्हेन अ बॉडी चेंजेस इट्स x y and z, all the coordinates, three coordinates at the matlab three coordinates are required, then it is called a 3D motion. Now let us understand two new concepts, distance and displacement. What is the difference between distance and displacement? हम नॉर्मली तो डिस्टेंस वर्ड को बहुत ज़्यादा यूज़ करते हैं कि मैंने इतनी डिस्टेंस चली, इतनी डिस्टेंस चली, लेकिन इसका मतलब क्या है और हाउ इज इट डिफरेंट फ्रॉम डिस्प्लेसमेंट. So suppose we take a particle which is at this point. Now it goes from, in a linear path, it goes from this to this point. Then it turns to its left and moves from this to this point. So let us call these points A, B and C. Now what is the distance traveled from A to B? The distance traveled from A to B is 3 units. But what is the distance traveled from B to C? The distance traveled from B to C is 4 units. So this is the meaning of the distance. Distance means the length of the path actually traveled by the particle. So the particle first traveled from A to B covering a distance of 3, then it moved from 0 to 4, from B to C covering a distance of 4 units. So this is distance. But this is not displacement. What is the displacement of the particle? The displacement of the particle is the shortest distance traveled between these 2 points, that is from A to C. This is the distance traveled. So distance traveled from A to C will be called the displacement of the particle. Now why am I putting this arrow? This arrow tells me the direction of the displacement. The displacement is a vector quantity and it must be specified with the direction also. So if I take a compass and find that this is the north and this is the east direction, then approximately when the particle moved from A to B, its displacement was 3 units towards east. When it moved from B to C, its displacement was 4 units to north. But the resultant displacement, if I talk of the total displacement from point O, A to C, then this displacement can only be calculated using Pythagoras theorem. So what is Pythagoras theorem? It states that you can always find the hypotenuse by this formula. The sum of squares of perpendicular and base. So the hypotenuse comes out to be 3 square plus 4 square followed by an under root, which gives me h. These 3, 4, 5 form a Pythagorean triplet. So h comes out to be 5 units. Now this h is my displacement. The displacement is shown by the symbol s, and s comes out to be 5 units. But when you talk of displacement, you will also specify the direction. So what is the direction of this displacement? It is towards northeast. So the displacement of this particle when it moves from A to C is 5 units northeast. So students, we come out with certain differences between distance and displacement. Distance moved is the actual length of the path traveled by a body, whereas displacement is the length of the shortest path traveled by a body from initial position to its final position. यानी कि कहाँ से चलना शुरू किया और कहाँ पर उसने अपना जर्नी खत्म किया, इन दोनों पॉइंट्स के बीच की जो सबसे छोटी दूरी होती है, shortest distance, that is called the displacement, right? Plus, I should mention here that the direction, which makes displacement a vector quantity and distance a scalar quantity, right? So, this is the difference between distance and displacement. You can note it down. Now, let us do two numericals on the concept of distance and displacement and see whether you have understood or not this the difference. So, what you see here is a square field of side 100 meters. Look at the question. A farmer takes 2.5 rounds of a square field of length 100 meter. If he starts from point A and takes 2.5 rounds of this square field, find the distance traveled and his displacement. Now think about this problem for a while, then I'll come to you with a solution. Yes, so the distance in this problem will be calculated by taking the total length of the path traveled by the farmer. So if he starts from this point A, then he goes one round, then 2 rounds, and another half. So he reaches the point P. So the distance between point A and P is how much? It is 100, 400 in a round, then 800 in 2 rounds, and another 200 makes it 1,000 meters. So the distance traveled by the farmer is 1,000 meters. No direction needed. But if I talk of the displacement of the farmer, then what is displacement? Displacement is the shortest distance between the starting point and the final point. So this diagonal is the displacement of the farmer, and I draw the arrow like this, again northeast, because he has moved from A to P. He has displaced from A to P. And what is this displacement? That you can find out, and it would come out to be 100 root 2 meters towards northeast, because 100 and 100 makes the diagonal 100 root 2. You can do the Pythagoras theorem and find out for yourself what is the displacement from A to P. So this is the distance and this is the displacement. Now another question to clear this concept more. Here you see the question. Find the distance and displacement as a point travels from A to B. See, I have specified the direction. It is going from A to B. A semicircular path. And let me mention that the radius is 7 meters. So, how will you calculate the distance? The distance is the total length of the path traveled by the object. So, it comes out to be how much? It comes out to be pi r, not 2 pi r. 2 pi r will be the whole circle. He is starting from A and reaching B. So, it is covering half a circle and covering 22 by 7 into this radius, which is 7 meters and 7 meters. So it comes out to be 22 meters. Now what about the displacement? The displacement between A to B is just the shortest line joining the starting point and the final point, which is this diameter, and it is 2r, that is 2 into 7 meters, 14 meters. But I have forgotten something. I have forgotten to put the direction. And what is the direction? What we are taking in this lesson in this direction is east. So east, 14 meters towards east is the displacement. So this is the concept of distance and displacement. I hope you have understood it. The next topic which we have to take up is the uniform motion and the non-uniform motion. I hope you remember that you had learnt in class 8th, 7th also that what is the difference between uniform motion and non-uniform motion. Can you tell me where does the concept of acceleration come? Suppose a गाड़ी zoom करके अपनी स्पीड बढ़ाती है तो वो यूनिफॉर्म मोशन है या नॉन यूनिफॉर्म मोशन है? Yes, it is non-uniform motion, and whenever you talk of non-uniform motion, what comes into play? The acceleration. So let us understand it in detail. What is the difference between uniform motion and non-uniform motion? Uniform motion. If a body travels equal distances in equal intervals of time, it is said to be in uniform motion. And non-uniform motion, if a body travels unequal distances and in equal intervals of time, it is said to be in non-uniform motion. The uniform motion and non-uniform motion, let us see examples. यहाँ पर मैंने डिस्टेंस बनाया है और रेड कलर से मैंने टाइम बताया. सपोज कोई आदमी या कोई पार्टिकल पहले था पॉइंट 0 पर O पर कवरिंग अ डिस्टेंस ऑफ 0 व्हेन द टाइम स्टार्टेड. इसको बोलते हैं इनिशियल टाइम, टाइम 0 जब था. इसके बाद ये मूव होते होते 1 सेकंड बाद ये यहाँ आ गया. 2 सेकंड के बाद ये इसने 4 मीटर के माइलस्टोन पर पहुंच गया. 3 सेकंड्स के बाद ये 6 पर था. 4 सेकंड्स के बाद 8 पर था. 5 सेकंड्स के बाद 6 पर था. 10 पर था और 6 सेकंड्स के बाद ये 12 पर था, एंड सो ऑन एंड सो फोर्थ. तो हम ये देख रहे हैं कि इस टाइम इंटरवल में यानी कि 1 सेकंड के टाइम इंटरवल में इसने 2 मीटर्स कवर किए. नेक्स्ट 1 सेकंड के टाइम इंटरवल में इसने फिर 2 मीटर्स कवर किए. नेक्स्ट 1 सेकंड के टाइम इंटरवल में फिर 2 मीटर्स कवर किए. सो द टाइम इंटरवल्स आर इक्वल, 1 सेकंड, 1 सेकंड, 1 सेकंड एंड 1 सेकंड. But what can you say about the distance? The distance traveled in an equal intervals of time is also equal, that is 2 meters. So this is uniform motion. Now what is non-uniform motion and how is it different? Suppose the object is at 0 meters at time 0 second. Now in the next 1 second, that is in a time interval of 1 second, it reaches this point covering a distance of 4 meters. In the next 1 second time interval, what is the distance covered by it? It is only 2 meters. What about in the next interval, which is same as earlier 1 second? The distance traveled here is 4 meters. So the time interval is 1 second, 1 second, 1 second, but the distance traveled are first 4 meters, then 2 meters, then again 4 meters, and again 2 meters. So the distances traveled are not equal. So this kind of motion, when unequal distances are traveled in equal intervals of time, एक एक सेकेंड का इंटरवल लिया है हमने, लेकिन जो डिस्टेंस ट्रैवल की कभी वो 4 मीटर चल गया, फिर उसने अपनी स्पीड जरूर कम की होगी इसलिए वो सिर्फ 2 मीटर कवर कर पाया. फिर उसकी स्पीड फिर उसने बढ़ाई होगी तभी वो 1 सेकंड में फिर से वो 4 मीटर कवर कर पाया, और इसके बाद उसने इसकी स्पीड फिर कम की होगी इसलिए वो सिर्फ अगले 1 सेकंड में सिर्फ 2 मीटर कवर कर पाया. तो क्या ये मोशन बिल्कुल एक जैसे चल रही है या अलग अलग डिस्टेंस ट्रैवल कर रही है? तो आंसर है अलग अलग डिस्टेंस. तो इस तरह की मोशन को हम कह सकते हैं नॉन यूनिफॉर्म मोशन. अगर हम ग्राफ देखें तो नॉन यूनिफॉर्म मोशन का ग्राफ स्ट्रेट लाइन नहीं आएगा. या तो वो इस तरह से हो सकता है, या शुरू में स्पीड ज़्यादा है बाद में नहीं है, तो इस तरह से हो सकता है. बट यूनिफॉर्म ये जो ग्राफ है ये टाइम और डिस्टेंस के बीच का जो ग्राफ है वो इस तरह से होगा. लेकिन अगर हम यहाँ पर डिस्टेंस और टाइम का ग्राफ बनाएं तो हम क्या देखेंगे? वो बिल्कुल एक स्ट्रेट लाइन. टाइम जैसे बढ़ता जाएगा वैसे ही डिस्टेंस भी बढ़ती जाएगी. Equal intervals of time and equal distance covered in every interval of time gives me a straight graph. So graphically the difference between uniform motion and non-uniform motion will be like this. अब आपने डिस्टेंस टाइम ग्राफ तो देख ली यूनिफॉर्म मोशन और नॉन यूनिफॉर्म मोशन के. नाउ आई विल draw the speed time graph, speed time graphs of uniform motion and non-uniform motion. You must know the difference between the two graphically also. This may be asked in the exam also. तो फर्स्ट केस में देखें तो स्पीड अगर 1 पर 2 मीटर्स पर सेकेंड थी तो 2 सेकेंड्स बाद भी वो 2 मीटर्स पर सेकेंड ही थी, 3 सेकेंड्स बाद भी वो 2 मीटर्स पर सेकेंड ही थी, 4 मीटर्स बाद भी वो 2 मीटर्स पर सेकेंड ही थी. इसलिए जो ग्राफ आएगा वो कैसा आएगा? फ्लैट ग्राफ पैरेलल टू टाइम एक्सिस. So this graph is telling you that the speed is not increasing during the uniform motion, but doesn't happen in case of non-uniform motion. Non-uniform motion में टाइम बढ़ता है तो स्पीड भी बदलती जाती है. जैसे मेरा जब टाइम 1 था तो से माई स्पीड वॉज 2 मीटर्स पर सेकेंड. आफ्टर 2 seconds माई स्पीड वॉज से 4 meters per second. Then again after 3 seconds it became, at 1 second it was 2 meters per second. After 2 seconds it was 4 meters per second. Let me delete this point. And after 3 seconds it was again 2 meters per second. So the graph goes like this and this. If it starts from 0 then it goes like this. And maybe after another 1 second it is still at 2, another one more second it is still at 2. So the graph overall does not have any uniform shape, any straight line shape. It is continuously changing. So this is the graph of non-uniform motion, the speed time graph. Now when you will study about acceleration, this driver is obviously giving some acceleration, so that its speed is increasing, then decreasing, then not changing anymore. So the concept of acceleration comes in, that is someone is changing the speed continuously, and non-uniform motion is the point from where we start the study of accelerated motion. So students, this was the difference between uniform and non-uniform motion. Let us do a few numericals on speed also. So speed is defined as the distance traveled by a body in unit time. Unit time is in 1 second or 1 minute or 1 hour. Unit means 1 per unit time. The speed is defined as the distance per unit time. Like when we say 2 meters per second means every second it is traveling a distance of 2 meters. After 1 second it is at 2 meters. After 2 seconds it is at 4 meters. Means every 1 second it is traveling 2 meters. So this is the definition of speed. Speed is distance per unit time. Symbolically, if I represent distance by s and time by t, then speed is distance upon time. Then the SI unit of speed is, you can find by this formula itself. The speed is distance upon time. So distance is in, if suppose it is in SI unit measured in meters and time is measured in seconds, so the unit of distance comes out to be meter per second. But when you see it on the speedometer of the scooter, what do you see? You see kmph written on it. 0, 10, 20, 30. So kmph means kilometers per hour. How many kilometers are covered per hour is mentioned here. So sometimes the speed is measured in kilometer. Practically it is measured in kilometer per hour. And when we do numericals or theoretical things, we use meters per second. The first question is, an object covers a distance of 30 meters in 5 seconds. Find its speed. So An object covers a distance. So let us first write down the given. For this question, answer 1. What is the distance traveled by the object? It is 30 meters. What is the time taken by the object? It is 5 seconds. So this is, you should write given. Then the formula used. What is the formula used? The distance speed is equal to distance upon time. So you get 30 meters upon 5 seconds and it gives you the speed to be 6 meters per second. Right? So 6 meters per second is the answer for the first question. Now, have you followed, students? So now let us come to the second question. An object starts moving at 3:30 p.m. and it reaches its destination 20 meters away at 4 p.m. Find the speed. Actually, I'm going to write 2 kilometers here. 2 kilometers because I am trying to bring in the concept of conversions also. So, in this question, what is given? Given is the distance is 2 kilometers and the time is, it started at 3:30 p.m. and it ended its journey at 4 p.m. That is 30 minutes. Now students, you must take into note that this kilometers and minutes are not used together generally. So either you have to convert this into hour, this gives you half an hour, or vice versa you can also do that distance is equal to, in SI units if you are asked to do that, the distance हो गई 2000 meters और टाइम को आप ले लेंगे 30 minutes. 30 minutes में कितने seconds होते हैं? वो हो जाएंगे 3 6 18 1800 seconds. So the formula is speed is equal to distance upon time. So if you use this formula you get 2 upon half, that is 4 kilometers per hour. 4 kilometers per hour. And if you to use this formula, velocity is equal to distance upon time, then you get 2000 meters upon 1800 seconds. How much it comes out to be? It is 10 by 9 meters per second, right? So these are the two ways in which you can do this. If you are asked to find it in SI units, then of course you should take care about the units. They should be in the same system of units, right? So this was about speed. Now students, you can see on the screen how to convert speeds from one system of units to other system of units. Like here in first question I have asked you to convert 18 km per hour to meters per second. In the second or third question I have asked vice versa, that is convert 20 meters per second to kilometers per hour. Let us learn them both and take care in future that we do not proceed further in numericals without the proper conversions. Now, here, what are you asked to do? You are asked to do, you are asked to convert 18 km per hour to meters per second. Now, this may be something new for you. Here it is kilometers, 18 km per hour. I have written like 18 km per hour. Per hour means per 1 hour. That is, in the denominator it is 1. So in order to convert it into meters per second, I have to convert kilometers to meters. How will you convert kilometer to meter? 1 kilometer is how much? It is 1000 meters. So 1 kilometer is 1000 meters. I taking this in mind, I'll do the conversion. 18 kilometer means I have to convert it by multiplying it with 1000, and in the denominator it is 1 hour. Some okay, 1 hour into 3600. When you solve it further, you will get 1800 upon 18,000 upon 3600. This goes off, and 36 5 times is 180. So you get the answer 5 meter per second. Normally the values which are given are in the numericals are in the uh, table of 18, multiples of 18. 18 that gives you 5 meter per second, then 36 gives you 10 meter per second, 54 gives you 15 meters per second, like this. Normally 72 gives you 20 meters. If you practice it more, you'll be accustomed with this type of conversion. So 36 kilometer per hour when converted to meter per second will give me, let us see, when I'll put 36 here, and let us see what happens. 36, I'm converting this now. 36 into 1000 meters upon 1 into 3600, that is 36,000 upon 3600. So students, how much it gives me? It gives me 10 meters per second. So this answer is 36 kilometers. As I told you earlier also, 36 gives me 10 meters per second. Now what about this 20 meters per second? First you should write 20 meters per second, and then my aim is to convert meter into kilometers and time seconds to hours. So I'll divide this by 1000 and 1 second by 3600 in order to convert it into hours. So when you do it all, you will get 72 kilometers per hour. This is how 20 meters per second can be converted into 72 kilometers. Next one can be taken as an assignment: conversion of 5 meters per second into kilometers per hour. So this was something very important, and you all many a times neglect this part of the physics. Conversions you should practice a lot. There is a lot of time, so you should convert many quantities. And the last topic, which I think cannot digest more than this. So the last topic which I am going to take up is velocity. Students, it's just a small addition in the speed. Like when you study distance versus displacement, डिस्टेंस वर्सेस डिस्प्लेसमेंट में आपने ये देखा था कि डिस्टेंस की कोई डायरेक्शन नहीं होती थी और डिस्प्लेसमेंट में डायरेक्शन भी होती थी. तो यहाँ पर भी आप यही देखेंगे कि डिस्टेंस जहाँ स्पीड होता है, स्पीड में कोई डायरेक्शन नहीं होती. स्पीड होता है डिस्टेंस अपॉन टाइम, जबकि वेलोसिटी होता है डिस्प्लेसमेंट अपॉन time. Velocity is defined as the displacement of the body per unit time. Velocity is displacement per unit time. So velocity is displacement per unit time. And what should be the unit of velocity? Should it be something different or the same? It is the same, because displacement is again measured in SI units in meters and time is measured in seconds. So the unit of velocity comes out to be meters per second. Sometimes it may be used as kilometer per hour. So velocity has both magnitude and direction, and it is a vector quantity, whereas speed was only a scalar quantity. So this is the difference between velocity and displacement. And with this we come to the end of our lecture. Have a very good day.